Hi everyone and welcome to the second class of number system. So I hope that you have watched the first class. My name is Nishant and I had taken the first class where we had started with concepts of classification of numbers. We had looked at real and imaginary numbers, complex numbers, rational, irrational numbers, fractions, integers, whole numbers, natural numbers, prime and composite, even and odd, and all that stuff. Then we looked at your rules of divisibility, and we looked at from 1 to 16 we looked at rules of divisibility for all the numbers, and finally we looked at sum of natural numbers, where we looked at natural number sum, square of natural number sum, and cube of natural number sum. And then we also sort of digressed and we looked at sum of even and odd natural numbers. I hope you have done all that. If not, please pause, go back to that video, watch that, and then you can come to this. Okay, so today we are going to touch upon one very important topic, which is LCM and LCF. Something very, very basic. You would have done this in school long back, but this forms the basis of so many questions that you'll be surprised how many places this can be applied. So we'll go through all that, we'll revise, and then we'll also look at some models. Okay, we'll look at 3 LCM models and 2 HCF models. Models basically means that there's some standard type of questions which we have categorized. Okay, and then we are going to look at a very small concept of successive division as well. Okay, so let's get going. Before we start, let me just familiarize you with some terms which we are going to use a lot. You might already know them, but in case not, this will be helpful. First is factors. Okay, factors, or we also call them as divisors. I had also touched upon them in the last class, where when we defined a prime number, I told you that a prime number has only 2 factors. Okay, or 2 divisors. Okay, so what is a prime number? What is a factor? A factor basically are all numbers which divide a given number. For example, if I have number 10 gets divided by 1, 2, 5 and 10, right? They get divided completely, they do not leave any remainder. So 1, 2, 5 and 1, 2, 5 and 10, these are factors of 10. Okay, so 10 has 4 factors. Okay, also they are called the divisors, but factors is a more common term. Okay, prime number has only 2 factors, because if you take 11 for example, 11 will get divided only by 1 and 11. So in fact, prime number has 2 factors, and those factors also always are 1 and the number itself. Composite numbers have always more than 2 factors, minimum 3 factors. And we also saw that number 1 is neither prime nor composite because it has only 1 factor and it's called a unique number. Okay, so basically that's a factor. How many factors a number has and all we'll do in the next class, where we'll discuss completely on factors. But right now just understand what is a factor. A factor is a number that divides the given number fully. Okay, then coprime. Now we discuss prime here. Prime number is a number that has only 2 factors, one in itself. Coprime exists when you have 2 numbers. Okay, so when I have 2 numbers, let's have number 10 and 12. Okay, what are the factors of 10? We just saw 1, 2, 5 and 10. What are the factors of 12? 1, 2, 3, 4, 6 and 12. Other than 1 we ignore. Other than 1, are there any other factors which are common between 10 and 12? Yes, you will see that 2 is common. 2 is a common factor. So if a pair of numbers have any common factor or factors other than 1, then they are not coprime. Okay, but if they do not have anything in common, okay, for example, let's take 9. 9 has factors of 1, 3 and 9. Now if you compare 9 and 10, do they have anything common other than 1? No. 10 has 2, 5, 10 and 9 has 3 and 9. There is nothing common. So 9 and 10 are coprime, 10 and 12 are not coprime. Okay, so basically coprime always exists when you have a pair of numbers, first and most important, and they should not have any common factor between them other than 1. Okay, so very simple concept. Now if you look at, if you have a prime number and another prime number, let's look at some combinations. If you have 2 prime numbers, they will always be coprime. because obviously prime numbers won't have any common factor. For example, 11 and 13. 11, 13 will always be co-prime. So prime and P1, P2, two primes will always be co-prime. If you have one prime and one composite, then they may or may not. Right? When will they not? For example, if I take 11 and 22. So 11 is a prime number. Its factors are 1 and 11. 22 is a multiple of 11. So this has 1, 11, 1, 2, 11 and 22. So you can see 11 is common. Hence, they may or may not be co-primes. And two composite numbers obviously may or may not be co-primes. Okay, so these are three scenarios and we just looked at all three. Okay, one important part here is that two consecutive numbers are always co-prime. Okay, you saw here 9 and 10. Similarly, you look at 10 and 11. You look at 11 and 12. You look at 12 and 13. Two consecutive numbers are always going to be co-prime. Please remember that, always very, very important. Okay, and then let's look at division. Division, of course, again you all know, but I want to give you a formula which again you would know, but we will be using that very frequently. Let's say I divide 75 by 6. Okay, this will get divided 1 times, you'll have 6, then you'll have 15, so 2 times you'll have 12, and 3 will be the remainder. Now this 6 is called the divisor, right? This is called the divisor. This 75 is called the dividend. Okay, this 12 is called the quotient. And this 3 is called the remainder. Right, all these 4 terms I'm sure you are aware. And divisor and dividend, because both of them have a d, normally divisor is a smaller number, so it is represented by small d, and dividend is represented by capital D, and the formula that we get is dividend is equal to divisor into quotient plus remainder. This is very important. You would know this, but please note this down, that dividend is equal to divisor into quotient plus remainder. Now what do I need to do if I need to make this dividend fully divisible? I don't want any remainder. I don't want any remainder. Now there are two questions or two parts to it. If you are allowed to reduce the dividend, then of course you can see that r you will take from the right hand side to the left hand side, and this equation will change to d minus r is equal to dq, and on the right hand side you will see that there is no remainder. So dividend should be reduced by the remainder. So in this example 75 minus 3, you will have 72, and 72 you can see will be your divisor, which was 6, into quotient, which is 12. Okay, so if you are allowed to reduce the dividend, you just subtract the remainder. If you are not allowed to reduce the dividend and you are only allowed to increase the dividend, okay, then you add d minus r, small d minus r. Okay, you see what happens on the right hand side also we add, this was already there, plus we add d minus r. You can see that r again gets cancelled, and basically you get d into q plus 1. Your quotient increases by 1. In this case 75, what do I need to add? It is 75 plus d, which is 6, minus remainder, which is 3. That means you're basically adding 3, so you make it 78. 78 is equal to, now your divisor is same 6, but your quotient instead of 12 will become 13. So your quotient will increase by 1. Okay, so remember that if you are allowed to reduce the dividend, then you subtract r and you have your answer. If you are allowed to increase the dividend, then you add small d minus r, which is divisor minus remainder, and you have your answer. Fine. Okay, so these concepts will come in between when we discuss. So I thought it's best that we understand them before we proceed. Okay, let's look at HCF now. Okay, HCF, if there are two natural numbers x and y, and the highest number which divides both x and y completely is called the highest common factor. That is the full form of HCF, or it is also called the greatest common divisor. I told you that factor and divisor we use interchangeably. Okay, so first thing, understand the numbers are given to you x and y. These numbers are the dividends because they are the one which are getting divided. And the highest number which divides, that means basically the HCF or the GCD is nothing but the divisor. What you are finding is a divisor. Okay, so in case of HCF, always remember dividend is given to you, divisor is what you are finding out. Okay, I hope that piece is clear. Okay, so let's see, let's take an example to understand. Let's say I have 20 and 25. Okay, these are my two numbers, 20 and 25. Let's say 20 is x and 25 is y. Okay, so basically now the highest number which divides both x and y is called the HCF or the greatest common divisor. So if you can see, x and y both will get divided by 5, right? This also gets divided by 5. This also gets divided by 5. Is there any greater number than 5 which can divide both of them? No. There is no such common number which can divide both of them. So 5 will be called the HCF or GCD. But HCF is the term that is more commonly used. Okay. So basically in HCF, the dividend is given to you. Divisor is what you have to find out. Okay. So 5 will be. Now how do we find this? There are two methods that is used. Now there are two methods to find HCF. The most common method is a prime factorization method. There is a second method also which is a division method. Not used much, but I'll tell you that as well. Okay, prime factorization method, focus on the two words prime and factorization. So we basically factorize the given numbers into prime factors. Prime is important. So 20 will be broken down into 2 into 2 into 5. So these are prime factors. 25 will be also broken down into 5 and 5. Okay. So once you have broken down, then you just look for common factors. So both of them have a 5. After I take 5 out, there is nothing else common. So since 5 is common, 5 is the HCF. Whatever is common, that is the HCF. Okay. So this is the prime factorization method. Let's take another number, 9 and 15, let's say. Okay, so if I look at 9 and 15, 9 factors are 3 into 3, 15 factors are 3 into 5. The common factors are 3, hence 3 is the HCF. Okay, so that's how you find out. Okay, let's look at division method also. So division method, what you do is basically you divide the larger number by the smaller number. So 20 divides 25. You will get it, divide it 1 times, 20, your remainder is 5. Now is the important part. Now with this remainder, you divide the smaller number. In your first division, the smaller number or the divisor was 20. Now this divisor will become the dividend. Okay, and you divide again. And this you can see gets fully divided. So with whenever the number gets fully divided, that is the HCF. Okay, let's do this for 9 and 15 also. So 9 will divide 15. You'll divide 1 time, 9. Your remainder is 6. Now 6 becomes your divisor and 9 becomes your dividend. 1 time, 6, 3. Now 3 becomes your divisor and 6 becomes your dividend. And this gets fully divided. So 3 is when it gets fully divided. Hence 3 is your HCF. Okay, so this is the division method, but this is a longer method, not required. Prime factorization method is the best method. And there is a third method, which is a shortcut method, which I always in fact suggest in most of the cases. That remember, if you look at 20 and 25, your HCF will always be lower than or equal to the smallest number. So HCF can be 20 or less than 20, right? So remember, smaller than or equal to the smallest number. Okay. Now what I would normally do is I will check 20. Does 20 divide 25? No. Then I will do 20 by 2. 20 by 2 is 10. Does 10 divide 25? No. Then 20 by 3. 20 by 3 is not integer, so ignore that. Then 20 by 4. 20 by 4 is 5. Does 5 divide 25? Yes. So answer is 20 by 4 or 5. So you just take the smaller number, divided by 1, divided by 2, divided by 3, divided by 4, divided by 5, and wherever you get integers, check does that number divide the larger number. As simple as that. Okay. Let's check for 9 and 15. So we'll start with 9. Does 9 divide 15? No. 9 by 2? 9 by 2 is not integer. 9 by 3? 9 by 3 is 3. Does 3 divide 15? Yes. So that is the answer. Okay. So this can be done manually. You don't have to write. You don't have to even break it into factors. Okay. Fine. Some couple of concepts. Let's understand. HCF of prime and co-prime numbers. Co-prime we discussed just now. So two numbers are said to be co-prime where their only common factor is 1. This we saw, right? They don't have anything common other than 1. For two co-primes, their HCF will always be 1. Okay, that is implicit when we say that the only common factor is 1. So obviously they won't have any common factor. So for example, if you look at 10 and 11, or let's say 9 and 10. So 9 and 10 are co-primes. Two consecutive numbers are always co-primes. So 9 is 3 into 3 and 10 is 2 into 5. You can see there's nothing common. So the HCF is obviously 1. Two prime numbers always co-prime. We saw that also. Co-primes can be both prime. So both prime will always be co-prime. Both composite can also be. One prime, one composite can also be. Okay. So this all we discussed. Okay. Let's do few questions on this so that we get this better. Okay. So find the HCF of 40, 84 and 168. So let's do the factorization method and then I will do the other method also which I discussed. We will not do the division method. Okay. So 40 is equal to 2. You have 20, 2, you have 10, 2, you have 5. So these are the factors of 40. For 84, you have 2, you get 42, 2, you get 21, 3, you get 7, 7. And 168 you can see is nothing but 84 into 2. So you'll get 1, 2 extra. The rest everything will be same. Right. So these are the factors. Now you just need to check what are the common factors. So you can see there's a 2 common. These are second 2 also common. Okay. Then there is nothing common. This 2 is there, but this does not have a 2. So 7 is there in 2 of them, 5 is there in 1 of them, 3 is there in 2 of them, 2 is, so you have to have common in all 3. So the only thing common is 2 into 2, which is 4. So their HCF is 4. Okay. Let's use the second method, which is, I would say is a better method, is take the smallest number 40. Okay. Does 40 divide 84 and 168? No. 40 by 2, 20. Does 20 divide? No. 40 by 3. Not an integer. 40 by 4, 10. No. 40 by 5, 8. 8 does not divide 84. 40 by 6, not integer. A lot of numbers are not integers and they will automatically get eliminated. 40 by 7, no. 40 by 8 is 5. So 5, no. 40 by 9, not an integer. 40 by 10 is 4 and 4 divides 84. 4 also divides 168. Okay. Divisibility by 4, I hope you remember. You can anyway check, but for 4, you basically need to check the last 2 digits. So 84 you need to check, and in 168 you need to only check 68. And since 4 divides 68, hence the answer would be this. Okay, 4 will be the HCF. You can also do this through the division method, but not really advisable. Especially here, division you will have to do twice. First 40 you will have to do with 84. Okay, so 2 times 80, then you'll get 4 remainder and 40, 10 times 40. So the HCF of 40 and 84 is 4. Now this 4 you'll have to try with 168 and this will divide 168 directly. So 4 is the HCF. But really this is the longest of all the methods. Okay, so I hope it is clear. These numbers basically are dividends. And the HCF that you are finding is the divisor, remainder, right? Divisor, remember that. Find the HCF of 2 to the power 100 minus 1 and 2 to the power 120 minus 1. Now this is slightly typical. Obviously, I'm not going to open this. But there is one concept that will be very helpful for this particular question. You should remember that a to the power n minus b to the power n is always divisible by a minus b. Okay, so a square minus b square is how much? A minus b into a plus b. A cube minus b cube is how much? A minus b into something we have here. A to the power 4 minus b to the power 4 is how much? A square minus b square and a square plus b square. A square minus b square again will give you a minus b, and then you'll have a plus b, and then you'll have a square plus b square. So what one thing you'll notice is all of them have a minus b as one of the factors. Okay, so all of them, whether the power is even or odd, they all have a minus b as one of the factors. And that's the concept we are going to use here. So if you see, the power is 100 and the power is 120. Now 100 and 120, the LCM is 20. That is very obvious. 100 is 20 into 5 and 120 is 20 into 6. So the LCM is 20. So what we will do is, let's write this as 2 to the power 20. Okay. To the power 5 minus 1 to the power 20 to the power 5. I can write it like this. So this is of the form a to the power n minus b to the power n, and n corresponds to this. Okay, a is 2 to the power 20, b is 1 to the power 20. So n corresponds to this. So this number is going to be divisible by 2 to the power 20 minus 1 to the power 20, which is a minus b. Similarly, the second number can be written as 2 to the power 20 to the power 6 minus 1 to the power 20 to the power 6, which gives you that this number is also going to be divisible by 2 to the power 20 minus 1 to the power 20. Okay, which again is a minus b. So both of them are going to be divisible by this. Hence this becomes their HCF. So the answer is 2 to the power 20 minus 1 to the power 20, and 1 to the power 20 means nothing but 1. So 2 to the power 20 minus 1. This is your answer, right? So this comes from this particular concept that you need to be aware of. Okay, fine. Let's move on. We'll do one more question. A milkman has 513 liters of milk of first quantity, 1134 liters of second quality, and 1215 of third quality without mixing. What is the minimum number of bottles in which all three qualities of milk can be poured? So again, these are bigger qualities and they have to be poured into smaller bottles, and you want the same size of bottles. Obviously that bottle should be the HCF, right? So that all these milks can be poured. So we will factorize this. 513. If you see first, it's an odd number. Is it a multiple of 3? 5 plus 1, 6, 6 plus 3, 9. Yes, it's a multiple of 3. So if I take 3 out, you will get 171. 171 is also a multiple of 3. So into 3, then 171 is going to give you 57. 57 is also a multiple of 3. It will give you 19. 19 is a prime number. So these are the factors. 1, 1, 3, 4. 1 plus 1, 2, 2 plus 3 is 5, 5 plus 4, 9. This is also multiple of 3. So into 3. So you will get 300. How much do I get? You get 3, then you get 23. So you get 7 times 21, then 378. 378 is also a multiple of 3. So into 3. This will give you 1, 2, 6. 1 to 6 is also a multiple of 3. So you get 42. 42 is also a multiple of 3. So you get 14. Okay. In fact, we should have taken out 2 first. Okay. The 2. 14 is 2 into 7. Okay. And the last one is 1215. 1215, 5 plus 2, 7. This is also 9, so that's also a multiple of 3. So let's take 3 out. Then it will give you 405, which is also a multiple of 3. So we take another 3 out. This will give you 1, 10, 3, 135, which is also a multiple of 3. That will give you 45, which is also a multiple of 3. Sorry, to 3. And then 45 is 15, which is again 3 into 5. Right? So 3 into 3, 9, 9 to 3, 27, 27 into 3, 81, 81 into 15. Yes. So these are the factors. So what are the common factors? The common factors are 1, 3 is common, second 3 is common, third 3 is common, nothing else is common. So 27 is the answer. The size of my bottle should be 27 liters. But that is not the question. The question is, what is the minimum number of bottles? In fact, understand from here also, minimum number of bottles means each bottle should be as large as possible. Hence, each bottle should be the HCF. HCF, remember, is the highest common factor. So it is the highest factor. 27 is not the only size of the bottle. You can have any factor of 27 also. So you can have bottle of 9 liters also. You can have 3 liters also. You can have 1 liters also. All these are fine. But the highest common factor is 27. So the largest size of the bottle is 27. Okay. Now, if you look at the first one, if you take bottle of size 27, 3 into 3 into 9, you will need 19 bottles. Right? So first case, you will need 19 bottles. Second case, if you take 3 into 3 into 9, what are you left with? You are left with 2 into 3 into 7. So you need 7 into 3, 21, 21 into 2, you will need 42 bottles. And third case, if you again take this, you will need 3 into 3 into 5, 3 into 3, 9 into 5, you will need 45 bottles. So total bottles that you are going to need is 45 plus 42, that is 87, 97, 107, 106 bottles. You are going to need 106 bottles. Okay, and that is the minimum. You can clearly see that if you use only 9, then your number will go up by 3. So you will need then 19 into 3, which will be 57 bottles. This will also become into 3. This will also become into 3. Your total number of bottles will become into 3. Okay. So 106 is the least number of bottles when the size of the bottle is 27 liters, which is the maximum possible size that you can have. Okay.